Welcome to today's discussion. Today we are going to look at the extraction of sulfur by Frasch process. And the question we have reads, the diagram below represents the extraction of sulfur by Frasch process. Study it and answer the questions that follow. Let us look at the short description of the process. That is the Frasch process. Frasch process is a special type of mining which involves sinking of three concentric pipes deep into the sulfur deposits, which occur between 150 and 200 meters below the ground. The reason why we use this special type of mining is because the soil layer above the sulfur deposits is very loose and can easily cave inwards, and therefore it does not allow the ordinary way of mining. So we have three concentric pipes of different diameters. We have the innermost pipe whose diameter is 2 centimeters. We have the middle pipe whose diameter is 8 centimeters, and the outermost pipe with a diameter of 15 centimeters. The outermost pipe of 15 centimeters in diameter carries hot superheated water at 170 degrees Celsius. Remember, the boiling point of water is 100 degrees Celsius, but this boiling point of 170 degrees Celsius is reached when water is heated under pressure. We also have the innermost pipe of 2 centimeters diameter, and this pipe carries what we call hot compressed air, and the work of the hot compressed air is to force the molten sulfur and water up the middle pipe. Then of course we have the middle pipe whose diameter is 8 centimeters, and this pipe carries molten sulfur and water onto the surface. Now let us look at the question that we have. Roman 1 of the question, name the substances that pass through L. We have pipe L, which is the innermost pipe, and the innermost pipe carries hot compressed air. Hot compressed air. We have pipe M. Pipe M is the outermost pipe of 15 centimeters diameter, which carries hot superheated water, and the purpose of hot superheated water is to melt the sulfur deposits. So this is superheated water. Then N, which is the middle pipe, this one carries the mixture of molten sulfur and water. We move down to Roman 2. Roman 2, what is the purpose of substance M? Substance M that we are introducing through the outermost pipe, which is hot superheated water, is to melt the sulfur deposits. That is to melt sulfur deposits. Remember, the melting point of sulfur is very low at 113 degrees Celsius, we have substance L being introduced through the innermost pipe, and substance L is hot compressed air, and its work is to force molten sulfur and water onto the surface. We move down to part B of the question, and part B reads, the chart below shows how sulfur 6 acid is produced on large scale by contact process, and the contact process is a process that manufactures sulfuric 6 acid. The flowchart begins from the point where we have solid B and gas A. Remember, anything that we introduce into the system represents our raw materials, and our raw materials in this case, we have sulfur, which is solid B. We also have gas A, which is either air or oxygen. The reaction between solid B, which is sulfur, and air, which is oxygen gas, produces gas C, which is sulfur 4 oxide. Then, of course, sulfur 4 oxide, which is gas C, reacts with more air to form sulfur 6 oxide. That is, sulfur 4 oxide is further oxidized in air to form sulfur 6 oxide. We proceed with sulfur 6 oxide into the absorption chamber, where it is reacted with substance E to form oleum. Sulfur 6 oxide is reacted with sulfuric acid, is reacted with sulfuric 6 acid to form oleum, which is H2S2O7. This is a liquid. This is also a liquid because this is concentrated sulfuric 6 acid. Then oleum is diluted with water to form the product that we are looking for. So we take oleum, which is H2S2O7. We dilute it with liquid D, which is water. And this reaction gives us 2 moles of concentrated sulfuric 6 acid. That is how concentrated sulfuric 6 acid is produced by contact process. So in case you are asked some of the questions that we can see here, you can be told to name, for example, solid B. Solid B is sulfur. We have gas A. Gas A is air. We also accept oxygen. Then we have substance E, which is concentrated sulfuric 6 acid. I'm using the abbreviations because of the space. We also have liquid D, and liquid D is water, whose molecular formula is H2O. Thank you for watching and welcome to the channel. And in case you have questions relating to this particular section, kindly interact with us in the comment section, and we shall be glad to address your concerns accordingly.